Hello students, welcome back to my channel. In the previous lecture we have learned about irrational numbers and in this lecture we will discuss about decimal expansions of the number, right? So for the decimal expansions we have to do a division of the numbers, and for the divisions we all know that this is dividend, this is divisor, this is quotient, and this is remainder, right? Now we will learn it by example number 5. Now what is example number 5? We have to show the decimal expansions of these three numbers. The third one is 1 by 7. Now for the first number, if I divide 10 by 3, I will get 3 as the quotient. Now here I will get 9. If I subtract it, I will get 1. Now this will not go on, so I have to put a decimal point. Now here we got 0. So if I put 3 here, I got 9 here. Now again same process. I have to get 0 here. Here 3, now 1. So this process goes up to infinite. So here I will get 3.33333 and go on, right? Now for the second one, 7 by 8. If I divide 7 by 8, first I have to put 0. So I will get 0 here, and it cuts by 8. So 8 8 is 64. Now this here I will get 6. Now again I have to put 0 here. Now here I will get 8 7s are, it is 56. I will get 4 here. Now again I have to put 0 here. Now here I have to put 5 because 8 5s are 40. 40 divided by 40. Now remainder becomes 0 here. So here the process of dividing is stopped because we got remainder 0. Now for the third one, and that is dividing 1 by 7. If I do the dividing process, my answer will become 0.142857, and it goes on repeating the same numbers like 0.142857 goes up to infinite, right? So I get three answers. Now for the first one is 10 by 3, my answer is 3.333. For the second one, that is 7 by 8, my answer is 0.875. And for the third one, 1 by 7, my answer is 0.142857, 142857, and it goes on up to infinite. Now if you focus on the remainder, you will get that there is two type of remainder. For the one is the remainder does not become 0, and here remainder becomes 0. So if the remainder becomes 0, that means the decimal expansion is stops at some point. Here you can see decimal expansion stop after 3 digit from the decimal point, right? So if the remainder becomes 0 at any point in division process, that means decimal expansion stops at some digit after the decimal point, no matter where it stops, but it will stop, right? So if the remainder becomes 0, that means the number is the stop means we will use term terminate for the term stops here, right? So that means the decimal expansion is terminating, right? And for the other, if remainder does not become 0, that means decimal expansion will go on for the infinite. That means it is non-terminating. We will simply use as non-terminating. Right? So you have to remember, if the decimal expansion, if the remainder is 0, that means decimal expansion is terminating. That means decimal expansion stops at some point. If it is not, if the remainder does not become 0, that means decimal expansion will go on for the infinite. That means it is non-terminating. So if anyone asks you how, which type of decimal expansion is this, you will say it is non-terminating because it does not terminate at any point, right? Here you will say it is terminating because it terminates at some point. And here also you will say it is non-terminating because it does not stops at any point, right? Now, in the this in non-terminating section, there will be a two part. For one, if the decimal expansion stops at some point, let me write it here. If I have to write this number, I can write it as 0.3 bar. Bar on the number shows that this number will repeat for infinite times. Here I cannot write anything like that, but here I can write it is 0.27 bar. The bar on the number says that 27 will repeat after this for infinite time, right? If I write like 276 and I will keep bar on these two numbers only, that means 0.2 as it is. Now I have to write 76 76 76, that will repeat for infinite times, right? So this number and this number are non-terminating number. This is also non-terminating number, but these both numbers repeat some pattern or some digits, but this number does not repeat any digit or any pattern. So we will tell this type of numbers recurring number. This type of numbers recurring number, and this type of numbers non-recurring. Or you can simply say it is repeating, non-repeating. If you divide any numbers and you get decimal expansions, and the decimal expansion is, first of all, it will be terminating or non-terminating. I can write examples here for the terminating 0.2, 0.576, 0.98. These are the examples of terminating number. For the non-terminating number, I can write 0.333, 0.12345, 0.272727. Right? These are the non-terminating numbers. Now, for the terminating number, we don't have any further parts. But for the non-terminating number, we have two parts. One is repeating number, other is non-repeating. Or you can simply write it is a recurring or non-recurring. Right? So if I have to give examples of repeating or recurring number, that also has a non-terminating feature. So I can write 0.333. This is repeating number. 0.2727. This is also a repeating number. Now for non-repeating number, I can write 0.12345 or 0.10, 100, 1300. Right? These are examples of non-recurring number. Now you can identify whether the number is rational or irrational just by these three type of decimal expansions. If you ever find a decimal expansion that is terminating, that means the number is rational. What I am saying is, if you ever find that the decimal expansion is terminating, that means the number is rational. Now if you ever find that the decimal expansion is non-terminating, then you have to look at the digits after decimal point. If the digits after decimal point is repeating or recurring, that means this is also a rational number. You can write 0.235335. This is also example of rational numbers, right? Now if you find that the digits after decimal point is non-recurring or non-repeating, that means this is irrational numbers, right? So for the rational numbers, decimal expansion of rational number is either terminating or non-terminating and repeating, right? Either terminating or non-terminating and repeating for the rational numbers. And also moreover, if the decimal expansion of any number is terminating or non-terminating and repeating, that means the number is rational number. And for the irrational numbers, decimal expansion should be non-terminating and non-repeating, right? So for the irrational numbers, decimal expansion is non-terminating and non-repeating or non-recurring. So it is very simple. For the rational number, decimal expansion is either terminating or non-terminating and repeating. For the irrational, it is non-terminating and non-repeating. This is the simple step to remember to identify whether the number is rational or not. Right? Now we will move on to the example number 6. Now example number 6. We have to represent 0.3 bar in the form of P by Q. Now 0.3 bar is non-terminating number, right? So we will remember a method to represent this type of numbers in the form of P by Q. So pay attention here, right? The first step will become, you have to assume x equal to 0.33333, and that is question, right? So in the first step you will assume let x equal to what is given in the question, right? This is your first step. Now in the second step, you have to multiply both the side with same number, and the number is, if you got a bar on a single digit, you will multiply it by 10. If you got a bar above 2 digit, like 0.27, here bar is above 2 digit, you will multiply it by 100. If the bar is above 3 digit, you will multiply it by 1000, right? So here bar is on single digit, so multiply it by 10 on both the side. So I get, if I multiply 10 on this side, I will get 10x. If I multiply 10 on this side, I will get 10 multiply 0.333. Now if I multiply 10 into this, I will get 3.333, and here is 10x. This is sign of therefore, right? So 10 is equal to 3.333. Now just assume that x equal to 2 and I get x equal to 5, right? No, here no, x equal to 2 and I get 5. So I have to separate 5 in such a way that I can use this x here. So if I write 5 in the form of 3 plus 2, so I can write x here because x equal to 2. I will do the same steps here. Here I have 0.33333. Now look at the x. What we have assumed as the x equal to 0.333. So I will separate this in such a way that I can use x here, right? So I can do, what I can do is just write what is x here and write the remaining part here. So what number that I have to write here such that the addition of this number will become this? Just write 3 here. So here 3 is because 3 plus 0.333 becomes 3.333, right? It is very easy. So here 3 plus in the we already assume this number is the x, so I can write x here. So here is 10x equal to 3 plus x. Very simple. Our first step will become, we have to assume the question equal to x equal to 0.333. Now second step is we have to multiply both the sides by 10, 100 or 1000. What will be the situation? We will do according to it. Here bar is on the single digit, so we multiplied it by 10. Now the third step is, after multiplying it, I have to separate this part such a way that I can use x here. So I have just written what is x here, and remaining part such that the addition of these two numbers will become this. Now I will write x instead of this because we already assumed that x equal to 0.333, so I can write it. Now here 3 as it is, 10x as it is. Now if I do further steps, let us put all the x on the one side and remaining part on the other side. So if I take this x on this side of the equal to sign, I will have to put minus sign, and here I will get 3. So 10x minus x, this becomes 9x, right, equal to 3. So x equal to 3 because 9 is in the form of multiply. If I put 9 on the other side of equal to sign, I have to do it in the dividing form. So 3 by 9. If I cut it, I get the answer 1 by 3. And this is our answer. It is in the form of P by Q, right? So I can write that 0.3 bar equal to 1 by 3. This is our answer. It is very easy. We just have to remember the method. And there is a 4 step in the method that you have to remember. First is to assume what is given in the question. Second is you have to multiply it by 10, 100 or 1000 according to the situation and according to the bar or the digit of the number, right? Third is you have to separate the number in the form such a way that you can use x instead of this. So I have to separate this number in the form of this. Now after placing x here, you just have to put all the x on the one side and all the numbers on the other side. Now just simplify it and you will get the answer. So answer is 1 by 3. The next example is also the same kind. Here 1.27 bar. Example number 7. What I have told you, the first step is, let us assume that x equal to 1.27. Now bar on 2 digit means 27 will repeat itself, right? Now the second step, I have to multiply both the sides by which number? Here you can see bar is above the 2 digits, so we have multiplied by 100. So let us multiply both the side by 100. So if I multiply both the side by 100, I will get 100x equal to 100 multiply 1.2727, right? So if I just simplify this, I will get, if I multiply 100 here, I get 127.272727, right? Now here it comes our most important step, and that is I have to separate this number such a way that I can use this. Just let me give an example so you can understand it. Here is 1.27 and I have assumed as x equal to 1.2, I have assumed x equal to 0.26, right, or 0.17. So if I have to separate this number, for the one side I will write 0.17 and for the remaining part what number I can write here so that the addition of those two numbers will become 1.27. First I have to write 1 and 1. 1.1 plus 1.17, 1.1 plus 0.17. The answer will become 1.27. We will do the same process here. What we'll do is we will write x as it is here 1.2727 and go on. Now what we will write here so that the addition of these two numbers will become this. So here I have 1 and here 127. So I will write 126. So 126 plus 1.2727 that equals to 127.2727, right? Here it is very easy because the digits after decimals are same as digits after decimals in x. So we do not have to do much here, right? Here I have 100x. Now I can write x instead of this because we assume that x equal to this. So 100x equal to 127 plus x. Now let us put x on this side. So 100x minus x equal to 126. Now it is very easy. 100 minus 1 equal to 99x equal to 126. Now if I put 99 on the other side, the answer will become 126 divided by 99. This is our answer and it is in the form of P by Q. You can divide it further to simplify it, or you will not divide, then the answer is answer stops here, right? So you can write it or you can also divide it further. So this is our example number 7. Now we will move on the example number 8, and that is or example number 9, 0.235. Here is another example of same kind. We will do the same process that we have done earlier in those two examples, right? First, we will assume that ax equal to 0.235. Here you will see that bar is on the these two digits only. That is 35, not on the 2, right? Now the second step, we have to multiply both the sides, and here bar is on the 2 digits, so we will multiply it by 100 only. So multiplying by 100, we will get 100x equal to 100 multiply 0.23535, go on, right? So here is 100x equal to, if I multiply 100, I will get 23.53535, right? If I multiply 100, the decimal points will go after 2 digits, right? So here 23.53535, right? Now our third step will become, we have to separate it such a way that I will get one part as a x and another part remaining, such that the addition of those two will become 23.53535. Now to do this, you have to focus on the decimal points. Here 353535 are done already, but here I have 2 and here I have 5. So let me write 0.2353535 so that I can use x here. Now here I have 5, here I have 2, right? So here I have 5, here I have 2. So I have to write 3 because 3 plus 2 become 5. Now these numbers covers under here. So 23.3 plus 0.23535, if I add these two numbers, I will get these numbers, right? This is very easy, just you have to use your mind. If you look at the digits after decimal points, you will easily separate these two numbers. Here is 100x. Now I can write x instead of this number. So this is 23.3 equal to 100x. If I will get all the x on the one side, then this becomes this. So here 99x equal to 23.3, right? Now x equal to 23.3 divided by 99, and if I remove point in from the numerator, so I will get the answer is x equal to 233 divided by 990, because I I have removed point from the numerator, so I have to add 0 in the denominator, right? So my answer is 233 by 990. So here is our example number 9. Now we will move on to example number 10. I have to find irrational numbers between 1 by 7 and 2 by 7. Process is very simple. First, you have to do a decimal expansion of these two numbers. So 1 by 7, we already done it in the example. So one decimal expansion of 1 by 7 is, I have to find irrational number between them, right? So decimal expansion of 1 by 7 is 0.142857, and decimal expansion of 2 by 7 is 0.285714, and it will repeat this number for the infinite time. So I can just simply put a bar here or here, right? This is the decimal expansion of 1 by 7, this is the decimal expansion of 2 by 7. Now I have to find a irrational number that is lie between these two numbers, right? So let me write a 1.5 here and 2.7 here, because if I write any number between 1.5 and 2.7, that number automatically comes between these two numbers, right? So I just have to write a number that comes between 1.5 and 2.7, or if you understand it directly, you can write any number between these two numbers. And for the irrational numbers, what was the condition? The number has to be non-terminating and non-repeating. So you have to write any non-terminating and non-repeating number between these two numbers. So I can write 1.5678 and it will go up to infinite. This is irrational number because it is non-terminating and it does not repeat the same pattern, right? Or you can write any numbers, like I will write 0.20, 200, 2300, or you can simply write 1.8765432110 10 11 12, any number you can write, but the condition is it should be non-terminating and non-repeating, and it should lie between these two numbers, right? So if someone asks you write a irrational number between 0.2 and 0.5, what will you do? You just will write 0.345678. This is the simplest way to write any irrational number, right? So these are those examples. Now we will move on to exercise number 3.3, right? Oh, sorry, 1.3, right?